and loop structures in Python. The if statement is a decision structure where a block of code is executed when the if condition evaluates to true. In the slide, we show the syntax of the single if statement that consists of a condition and a body. The if-else syntax contains an else block that gets executed when the if condition evaluates to false. And the nested if statement in Python, it's called if-elif-else, that nests several conditional blocks in addition to the else block that gets executed when none of the conditions evaluate to true. Some Python-specific syntax: blocks should be indented, and there's a colon after the condition and the else. Here's an example of a single if statement. A variable called a is initialized to 20. The condition states if a is greater than 10, which is true, then print greater than 10 is true. Outside the if block, there's an independent statement, print by, that will always be executed. The condition on the second example evaluates to false because 20 greater than 30 is false. So the print statement a greater than 30 is true is not going to be printed and will only have the independent statement by printed. In this slide, we slightly modified the previous example by adding more statements to the if block, but the behavior remains the same. So a greater than 10 evaluates to true, then we will have the 3 print statements executed and then the 2 independent statements executed. On the other side, where the condition evaluates to false, only the independent statements are going to be executed. The if-else statements add an else block that gets executed when the if condition evaluates to false. Back to our example, 20 is greater than 10. So a greater than 10 is true is going to be printed, then the independent statement print by. On the other side, the condition evaluates to false because 5 is not greater than 10. So the else block is going to be executed and a greater than 10 is false will be printed. Finally, print by the independent statement will be executed. The if-elif-else statement nests several conditions. When a condition evaluates to true, its block gets executed. If all conditions evaluate to false, then the else block gets executed. In the first example, the score variable is initialized to 84. The first if condition, score greater than or equal 90, evaluates to false. But the second condition evaluates to true, and you got a B gets printed along with by. On the other side, we slightly modified the conditions. The first condition, score greater than or equal 70, evaluates to true, and you got a C is printed along with by. Here's a couple of mistakes that happen when writing if statements. Note that the indentation of the statements in the if block is not consistent. So the first 2 statements, they are correctly indented, but not the third statement, which is going to cause indentation error. On the other side, the indentation of the second statement in the if block is inconsistent, which is going to cause a syntax error because this is going to be processed as an independent statement that comes after an if block. But when the interpreter sees the else, so it gets confused and gives you an error. In the second part of this lecture, we will cover the range function, looping structures, for loop, while loop, nested loops, in addition to the break and continue constructs. The range function returns a list of numbers that start with the starting number and ends with the ending numbers minus 1, because end is exclusive. Also, you can specify the increment between the numbers. So if you don't specify the step value, you will get an increment of 1. Let's take a look at these examples. Range of 10. Here we only specify the end, which is exclusive. So we get the sequence from 0 up to 9. Next, range 3 and 10, we get a sequence that starts from 3 and it ends at 9, and the increment is 1. Next, we have a sequence that starts at 2 and ends at 10 minus 1 with an increment of 2. So we get 2, 4, 6, 8, and because the next number would have been 10, but 10 is not included, so we get the last number as 8. In this one, we have the start greater than the end, so the result is an empty list. Also, the range function parameters can be negative, of course, as long as the start is less than the end. The negative increment results in a reverse ordering of the result list. Now we move to loops. A definite loop is a loop that executes for a specific number of times. For loops and counter-controlled while loops are the most common definite loop structures. For the case of the for loop, the range function controls the number of iterations. Consider the for loop in this slide. For I in range of 10, print I. So range of 10 is going to produce values from 0 up to 9, and this is what's going to be printed. In the right-hand side, we have the syntax of the counter-controlled while loop, where the loop counter is initialized to 0, and the while condition loops as long as I is less than 10. Here, we print the value of I and increment I by 1 on each iteration. Indefinite loops are those loops that execute for a number of times that we don't know yet. Maybe because the loop condition depends on a value that we are going to read from the user, or maybe we are looping over lines from a file and we don't know how many lines are there. So when the condition evaluates to false, this type of loop terminates. There's a situation sometimes we get into is called infinity loop, or loops that never terminate. Sometimes if we have a bug in the program and we didn't pay attention that there is no action is going to make the loop condition evaluates to false, then this happens as in this example. We have a while loop, I equals to 0, and the condition says that I less than 10. The body prints the value of I. But since there is no statement that updates the value of I, so the value is not going to be changed and the result will be an infinity loop. The break construct is used when we want to terminate the loop if some condition is satisfied. And the continue construct is used if we just want to terminate the current iteration. So let's take a look at the first example. In this for loop, the values of I are going to be 0, 1, 2, 3, and 4. We have a condition. If I equals to 2, we print we are breaking the loop, then break. Otherwise, we print the current value of I. So when I is 0, the condition is false, so we only print 0. Then when I is equal to 1, 1 is not equal to 2, we only print the value of I, which is 1. And when 2 equal to 2, the condition is going to be true. So we hit this if statement, we print, we are breaking the loop, and then break. On the other hand, the continue is used to terminate the current iteration only. So in this loop, we have values again 0, 1, 2, 3, and 4. And we want to skip this print statement when I equal 2, because when we hit the continue, just we go back to the next iteration, and anything underneath the continue is not going to be executed. So when I is 0, the condition is going to be false. We only print 0. When I is 1, we print 1. When the condition is true, is 2 equal 2, we print the statement. We are skipping this iteration, and then I becomes next time 3, and we get 3 and 4 respectively. A nested loop is a loop where the body of the loop is another loop, which means for each iteration of the outer loop, the inner loop will be executed. And here we have an example where we are interested in printing the prime numbers between 3 and 15. So we want to get these 3 to 15 values, so I need a loop to generate these values. So the outer loop is going to generate these values 3, 4, 5, 6, and so on. And the inner loop is going to test each value and whether it's a prime or not. And if it's prime, it's going to print it. And as you know, that the prime number is the number that divides only by 1 and itself. So each time we inspect a number, we assume that it's a prime until something inside the inner loop tell us no, this number can be divided by something else, so it's no longer a prime. So this is the function of the inner loop. The inner loop is going to iterate from 2 until the number, and with using the modulus, we will know whether it can be divided by another number. So if the modulus is 0, then this cannot be a prime number, and we set the S prime to false. So this is the idea of the nested loop, that we have an outer loop that just generates some values, and for each one of these values we are going to perform an iteration of another loop. With that, we conclude this lecture. Thank you and good luck.